Hello. Today we're going to go ahead and talk about the angle addition postulate. The angle addition postulate basically says that if you have two angles who sit right next to each other by sharing a side or a ray and a vertex, the angle of the combination of those two angles, the big one, or in this case my ABC, is simply the addition of my first piece, my angle ABD, plus my angle of DBC. So essentially what that looks like is angle ABC is equal to angle, hold on one second, ABD plus angle DBC. Just like when you have, say, pretend, a nice straight ruler. I know that's not very straight, but we're going to go ahead and pretend. We know that my ruler is typically 12 inches in length. If I say that I draw a line at 3 inches, I therefore must have to have 9 inches over here, because I will always have that 12 inches to work with. It's always my 12-inch ruler. This sounds very similar, if you recall, the line segment addition, which again is where I'm pulling all of this information from. So if you are aware of your line segment addition postulate, then you are ready to go for this angle addition postulate. One of the first things we need to remind ourselves is the definition of bisecting. Remember, by bisecting, we mean we cut something into equal parts. If we go back to my ruler for a second of 12 inches, we know when we cut that baby in half, that first side has to have 6 inches, and the second side has to have 6 inches. Okay, let's go ahead and look at problem number 1. We're told in problem number 1 that we don't know what angle ARB is. We know that angle BRC is 48, and that angle ARC is 78. So what this is saying is we don't know this value. So we're going to just call that our unknown angle. According to my angle addition postulate, if I take angle ARB plus angle BRC, I'll get angle ARC. So what that's saying is my unknown plus the part I'm given will equal the total part. Well, we've seen stuff like this, simple little equations. We know that in order to find my unknown, or my x here, all we have to do is the inverse operations. So we're going to go ahead and get rid of that 48. Now, the inverse of addition is subtraction. So we should know that our x, would be 30 degrees because it's 78 minus 48. Go ahead and check with your calculator. I'll give you a couple seconds. We agree? Excellent. Let's go ahead and move on to problem number 2. Now, problem number 2 looks a little bit more scary, but I promise we can tackle it just the same. So my angle addition postulate tells me that I can take all of the same angles that are in one diagram and add them all up as long as they share a connecting ray or side and vertice. Now, if you notice, all of these angles meet at angle J, so they all share that same vertex. And we see that this first angle shares a side with the second angle, and that second angle also shares a side with that third angle. So we know we can go ahead and do my angle addition postulate here. So let's see what we need to know. Well, it looks like we have a question mark on angle YJN. So we're going to call that our unknown. And we're going to call that x again. Why? Because x is just one of those variables we always use, and it's not named in any of my diagram. So I can go ahead and use it. I don't want to confuse myself by throwing in the same letter twice. So we want to find that unknown piece. So we're going to go ahead and take my unknown piece plus the second angle, which is 42, plus the third angle, which is 104. And it's telling me over here up to the right that that whole big angle YJK must be 160 degrees. So what we're going to do first is we're going to go ahead and combine my like terms. 42 plus 104 gives me 146. Next, I'm going to go ahead and do my inverse operations to go ahead and get my unknown by itself. 160 minus 146 gives me 14. So that unknown angle up here is 14 degrees. Let's go ahead and take it something a little bit more complicated, but I promise we can do it. Now in problem number 3, you'll notice that we don't just have numbers by themselves. We don't have the given angle measure. For the given angles, we are given variables. So we're going to approach this the exact same way we just did problem number 1 and 2. The only difference is now we have some thrown in variables. So we're told that that first angle of 2x and my 5x plus 8 is equal to 71. The reason I know this is just like with all the other problems, we've been taking our pieces, adding them together, and setting it equal to whatever it's telling me the big angle is. I see over here to the right, my big angle is a total of 71, so we only have 71 degrees to work with. So I'm going to go ahead and combine my like terms. Now my 2x and my 5x are on the same side of my equal sign. So that means I can go ahead and do the operation I see. So I have 2x plus 5x, which gives me 7x. My plus 8 does not disappear, so it comes down. And again, we're still equal to that 71. That has not disappeared yet. Next, what we're going to go ahead and do is my inverse operations to get rid of this plus 8. Remember, whenever we have one-term variables in my equations, we have to undo our subtraction or addition first before we can get to our multiplication and division. So that gives me 7x being equal to 63. Oops, that was a bad 63. Give me 1 second. Let's fix that up for you. Now, like I had said before, we have my x with my 7, which is being multiplied, so we're going to undo that multiplication with division. So it's telling me that my x is 9. Now, my question for you is, have I finished that problem? Take a couple seconds and think about it. I'm hoping you've come to the same conclusion that I have, that we haven't actually answered anything. All we've done is found our unknown variable of x. But I know that both angles cannot be 9 degrees, because 9 plus 9 does not give me that 71 that I know I have to work with. So what we have to do with that unknown variable that we just found is we're going to have to plug it back in. So I know that first angle of ALU, or this one right here, is 2 times x. Well, my x is 9, so I'm just going to take 2 times 9. Which gives me a value of 18. So that first angle must be 18 degrees. My second angle is 5x plus 8. Again, we're going to have to go ahead and plug that 9 in. So I have 5 times 9 plus 8. 5 times 9, ooh, sorry about that. 5 times 9 gives me 45 plus 8. 45 plus 8 ends up giving me 53. So that angle must be 53. Let's just double check that our calculations are correct. Why don't you grab your calculator? I'll give you a couple seconds. And in your calculator, I want you to plug in 18 plus 53. Are we getting 71? Cool. Looks like we've got the right answer. And if you're ever unsure about these, just double check. You know what the total angle should be. All right, let's go ahead and take a look at number 4. We're going to start this problem just like we had started all the other ones. We're going to add up my pieces and set it equal to my total. Well, my first piece is 5n minus 1. My second piece is 76. And my total is 12n. Now the difference here on this one is that I have my unknown variable, one on one side and one on the other. what we're going to have to do here is we're going to combine the things on the same side together first, and then tackle that here in a moment. So what I'm going to do first is I want to take a look at what's the same on my one side. Well, I see I have a -1 and a 76. Those are both the same term. They're both numbers. So I'm going to go ahead and combine them. So I have 5n plus 75 being equal to, so again, being equal to 12n. Next, we're going to approach that having two n's on opposite sides. So we have these same variables or like terms, just not on the same side. So we need to get one over to the other. Now, if I move over my 12n, I'm going to get an ugly 0 in the equation. And I don't want a 0 here. Not yet anyways. So what I'm going to do is I'm going to move my 5n over to hang out with my 12n. Now, my 5n is positive right now. So to undo that addition, or that positive term, I have to subtract it. So that's going to give me 75 is equal to 7n. All right, just like what we had done before, is we need to get our variables separated from our coefficient, or that number out front. So we're going to go ahead and divide. And when we divide this out, we see that my n value is about 10.71. Remember, always round to the second decimal. Now I question you, are we done with this problem? Hopefully you've come to the answer of no, because we still have to determine what this angle measure is. We know this one is 76. That one was given to us. But we also don't know what our total is. What we're going to do is we're going to go ahead and plug in our 10.71 into our missing stuff. So I have 5 times 10.71 minus 1, because I just plugged that value in for n in n's place. I get 53.52 minus 1, which gives me 52.52. Then what we're going to do is we're going to go ahead and check my total value of my angles. So that one was 12n. So I'm going to take 12 times 10.71. And that gives me 128.52. Again, your decimals might be off by a couple values, a couple tenths, which means that second number, not the first one. So if you get about 10.5, or excuse me, if you get 52.55, you'll be okay. It all deals with the rounding. So as long as you get very close to this answer, you'll be okay. And let's double check. Let's take that 128.52 minus 76, and let's see what we get. I got that 52.52. Did you guys as well? Excellent. Let's go ahead and move on to another example. Number 5. Now, I know number 5 looks very scary, but all we really need to do is take a look at what information has been given to me. So it's telling me some values for angles. I see that one of my angles, WYV, is 4x minus 2. Well, let's locate that on my diagram. WYV. So that looks like that angle is over here. So I know that that is 4x minus 2. Okay, what else is being told to me? So I did this one. I have angle VYZ. Okay, VYZ, looks like that's down over here, is 2x minus 5. Okay, took care of that one. And then I see angle WYV is 77. Well, WYV is this whole giant angle. So have we really changed any of our approaches? This should look exactly the same. The only difference with problem number 5 is we just have more unnecessarily things given to us. That's what they try and do. They try and scare you a little bit. But I promise, we can handle it just like we did the one before. So my two pieces added together gives me my 4x minus 2 plus my 2x. Let's fix that real quick. 2x minus 5 gives me that total of 77 like we talked about. This time we have two sets of like terms. I have my x's, which again are on the same side, so I can do the operation I see. So 4x plus 2x gives me 6x. And then I have my constants, or just my plain numbers, -2 and -5. So I'm just going to take -2 minus 5, which will give me -7, giving me that total of 77. So we're going to go ahead and approach this like any other equation now. We're going to undo that -7, which will give me 6x equaling 84. Then we're going to go ahead and divide both sides by 6. And x is 14. Okay, so we know that x is 14. But have we answered my question? Well, I can see that I have a question down here asking me what these two angles are. It wants to know. So now what we have to do is we do have to go back and plug them in. So my 4x minus 2, or angle WYV, means I'm going to have to take 4 times 14 minus 2, which gives me 56 minus 2, which gives me a total of 54. So that angle over there is actually 54 degrees. Let's take a look at finding my second one. Now, if you haven't caught on what we can do to find the second one, there's two different ways to approach it. We could plug it in. And have my 2 times 14 minus 5. Or I could take my total of 77 minus the 54 that I just found. Either way, it should give you my answer of 23 degrees. Feeling pretty confident? Good. We've got a couple more and then we'll be done. Let's take a look at number 6. All right, number 6 has nothing on it, so that means we're going to have to label it ourselves. So let's go ahead and go through what's being said. So first one, QS bisects RQP. Bisects. We learned that at the beginning. Let's take a look back at what that definition was. Bisects. Cut into 2 equal parts. Okay. So that must mean that QS, all right, well, where's QS? QS is over here. QS cuts that whole big angle of RQP, which is the whole resulting angle. So that means that this little part here is actually equal to this whole thing here. Now, I know it doesn't look like that, but we can't go based off of sight when we're in math class. We have to go by what's given to us, what information we know. And I know it bisects, so therefore they must be equal. Okay, so we've taken care of that piece of information. The next part's saying that angle RQS is 2x plus 10. So that RQS is that first little bit over here, so 2x plus 10. And angle SQP, hey look, that's the other half, is 3x minus 18. It wants us to find it wants us to find the angle measure for angle RQS. All right, so we want to find this first little piece over here. In order to approach that, we need to go ahead and set up an equation. You're probably thinking to yourself, I have no numbers to work with. What the heck am I going to do? It all goes back to that first word we took a look at as bisect. Remember, bisect made things equal. So it's saying that my two pieces that I'm given are equal. So if two things are equal, let's just set them equal to each other. Okay, so now we're going to approach this problem like we had one of the problems before. I think it was number 4, where we had variables on both sides. We want to get one of the variables to the other one. Now I'm going to try and do this as easy as I can. If I move over this 3, if I undo that 3, I know it's going to give me some negatives in there, so I don't want to do that. So what I'm going to do is I'm going to move over this 2. That leaves me with a 10 on this side. 3x minus 2x gives me 1x, or just simply x. And that minus 18 comes down. Now we're left with just a variable on one side. We've approached these all day. We know what to do next, my inverse operations. So that's going to give me a value of 10 plus 18, which is 28. So x is 28. But if I look back, it wants to know what that angle was, not just my value of x. Well, the QRS is that first piece, so that's 2x plus 10. So we're going to use this little expression. And what we're going to do for our x is my unknown that we just found. So I'm going to have 2 times 28 plus 10. 2 times 28 gives me 56, plus 10 more gives me instead of 66. So that angle, RQS, 66 degrees. All right. Got a couple more things to go on to. Now, before we can get to the last 2 problems, we need to remind ourselves about factoring. Why? Because factoring comes up all the time. I'm going to scoot these guys down a little bit because I write so big. So if you've forgotten how to factor, we're going to take a little trip down memory lane. We know that factoring is the opposite of foiling. It undoes foiling. So we're going to get 2 sets of parentheses here. We know that this first term of x squared was whatever this was times this was. Okay, well the only way to get to x squared is x times x. So that first piece in my 2 little parentheses are going to be x's. Cool. Makes my life easy. But what about my last 2 pieces? That's what comes with my -3 and my -10. So when we deal with factoring, we take a look at the last term first, or my -10. And we're going to try and figure out what multiplies to a -10, but then we'll add to a -3. So let's take a look at those factors of 10. I have 1 and 10, 2 and 5, nothing in 3, 4, back to 5. Okay, so I've got 1 and 10, 2 and 5. Can I use one of these 2 to try and get me to 3? Well, if you recall, 2 and 5 somehow get me to 3. Okay, so I'm going to have a 2. I'm going to have a 5. But I need to figure out what kind of signs I have, because I'm not just going to have x blank 2 and x blank 5. I need to have plus or minus. Well, that goes back to the signs that I have here. I have 2 negatives. That means I'm only going to have 1 negative in my final answer. So what would have to be the negative? If I had -2 and a positive 5, well, that gives me a positive 3. That's not what I want. So I must therefore have a positive 2 and a -5, because -5 plus 2 gives me -3. All right, let's take a look at the second one. Now that we've jogged your memory here of how to factor. I have x squared minus 2x minus 24. So I'm going to start with my 2 sets of parentheses again. The only thing multiplying to x squared can be x. Now, what multiplies into a -24, but then adds to -2? All right, let's look at my factors of 24. I've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Will one of those give me 2 and 2? You might have spotted it right away, the last one. 4 and 6. Just like with the first example of factoring, I want to figure out what my signs are. Again, I have 2 negatives. If I have 2 negatives, my bigger number is going to be negative. My other answer, my smaller number, will be positive. All right, let's take a look at number 3. Start with my 2 sets of parentheses again. If you haven't noticed pattern yet, if there's just an x squared there, first spot in each parenthesis set will be an x. Now, we need to look at what multiplies to negative 30, but adds to a negative 1. My multiples of 30 are 1 and 30, 2 and 15, 3 and 10. 4 doesn't go in, 5 does though, 6 times. 7 doesn't go in, 8 doesn't go in, 9 doesn't go in, back to 10. So, of those multiples, do you see my answer there? Yeah, 5 and 6. Just like with the last two, when I have 2 negatives, my bigger number gets the negative sign, smaller number gets the addition sign. Okay, last problem. X squared minus 16. This one's a little different than all the other ones. Okay, so if I have just 2 terms, I'm going to take a look. Are both of those perfect numbers? Meaning they can only multiply one number multiplied into it. So our perfect numbers, if you can't remember, are 1, 4, 9, 16, 25, 36, 49. What are those numbers? Well, it's 1 times 1 gives me 1, 2 times 2 is 4, 3 times 3 is 9, so on and so forth. Well, I see the only thing multiplying into x squared can be x and x, so that's perfect. Check. Mental check. So let's take a look at 16. Do I have the same number that multiplies by itself to give me 16? Right, 4. 4 times 4 gives me 16. So this is what's called the difference of 2 squares. I know we've seen this before, but it's been a while, so I wanted to make sure we remembered what to do. So when I have the difference of 2 squares, it's actually the easiest factoring I have. I'm going to go ahead and do my parentheses. We already know that the only thing multiplying to x squared is x times x. Well, we just talked about 4 multiplying by 4 gives me 16. So those can be my only 2 numbers to go here. But next we have to worry about the signage. Well, because there's no middle term, it's 1 plus, 1 minus, always. All right, now that we just reminded ourselves on how to factor, let's take a look at the last 2 problems, putting everything we just learned together. So, taking a look at the problem on the left. Angle ABC, or that whole big angle, is 51 degrees. We see that x squared plus 1 is angle ABD, and negative 5x is angle DBC. So we're going to go ahead and we're going to add these together using my angle addition postulate. So I have x squared plus 1 minus 5x is 51. Now, whenever we see expressions, we like to put them in descending order, meaning that we put the biggest value first, or the biggest x value. Well, x squared is first, because that's the biggest, minus 5x plus 1, 51. Now, the reason I have that negative sign with my 5, if you recall, is that the sign associated with a number in front of it gets tagged along. So now what we're going to need to do is we're going to figure out how we're going to factor this. Well, if we go back a slide, we saw that we didn't have any equal signs. We just had expressions. What we're going to do now is we are going to go ahead and set everything equal to 0 before we factor. So that meaning that we have to get rid of this 51. Well, how do I get rid of it? Well, I simply do the opposite of what I see. I use those inverse operations again. We're going to subtract it. So I have x squared minus 5x minus 50 is equal to 0. Now what we can do is we can go ahead and do our factoring like what we did before. Only this time we have that equal 0 part. So we should know that this first part is x. All right, let's talk about what goes into 50 but adds to 5. Have you got it yet? If you came up with 10 and 5, you're on the right track. If not, we'll take a look at those multiplication charts later. Now we know that the 10 has to be negative in order to give me that negative 5 answer over here. Now this is the part that's a little bit different than the slide before, because once we got to this part, we just stopped. But we know we have something equal to 0, because we have this equal 0 part. And this is where the cool part happens. If two things multiply together equal 0, that means one or both of them must be equal to 0. So that being said, either x minus 10 is 0, or x plus 5 is 0. Oops, forgot that equal sign. Well, that means x would have to be 10, or x would have to be negative 5. Again, we did all those inverse operations and we determined all those answers. Okay, so how does this play in to my original problem? X of 10, x being 10, and x being negative 5. Well, now both of these can be my answer. If I plugged in 10 here, that would give me an answer of negative 50. Just like when we deal with distances, we can't have negative values, can we? We can't. It just turns into attempts to try and be black holes, and it's just bad things. So because this gives me that negative 50 value, 10 cannot be one of my answers. So my x has to be equal to negative 5. If we plug that in, we know that I get 25 plus 1, which gives me 26. And negative 5 times negative 5 gives me 25. Just 26 plus 25 give me 51. Yep. All right. We're done with that first one. Now let's take a look at that second one. So we see that angle ABC is x squared plus 5. Angle ABD is 20. And angle DBC is negative 2x. Okay. So I have 20. I almost wrote 20 plus negative, which is fine, but we don't tend to do that in the math world once we understand that a plus minus just means minus. So 20 minus 2x is equal to x squared plus 5. So just like when I had started the problem before, I put everything in descending order and then got it set equal to 0. Well, I'm going to go ahead and just do that in one step. It's going to make my life a little bit easier and save me room. So I'm going to subtract 20, and I'm going to add 2x. So that'll give me 0. Now, as long as you keep your signs the same, does it matter which side of the equal sign the 0 is on? No? Cool. We're in business. So again, descending order. My x squared comes first. Then comes my x. Well, we're going to add it, so it's going to be positive now. Then my plus 5 and my minus 20. Now, 5 minus 20 gives me negative 15. So I'm just going to go ahead and write in that minus 15. All right, on to the factoring part. So we have my 0. We have my two sets of the parentheses. X is in the first spot because the only thing that can multiply to x squared is x times x. Now we need to figure out the factors here again. Negative 15. What multiplies to negative 15, but then we'll add to 2? What about 5 and 3? Now this example is a little bit different because we have a positive term here. So do I want my 5 to be negative? Nope. I want it to be positive in this case because that is the only way that I'll get that positive 2 is 5 minus 3. Just like with before, I can go ahead and set my pieces equal to 0. Because again, if two things multiply together to give me 0, that means one or both of them has to be 0. So we have to check about both of them. Inverse operations tell me that x is negative 5 and x is 3. So again, just like we had done in the first one, we have to check to see if either of these two will give me a negative value in here. Okay, let's check my negative 5. Well, nothing's going to happen over on this one. My A, oh, I lost my value over there. My B, nothing's going to happen to my angle ABD. It's going to stay the same because it's just a constant. Okay, let's take a look at over here. Negative 2 times negative 5 will give me a positive 10. We're all good. What about up here in my answer? Negative 5 squared is negative 5 times negative 5, which gives me 25. Plus 5 more is 30. All right, well, that one works. What about my 3? Does my 3 change this one? Nope. But what about this? It's going to give me a negative 6. Can we have negative angles? Nope. Goodbye, 3. Answer's 5. We already said that this one over here is 10. That's 20. And we said that was 30. All right, that's all I have for you today. I hope you had fun learning about the angle addition postulate. Check back for more videos.